Okay, so just before we go into some specific element examples, I just wanted to show you again on the periodic table where you can find this information. So this is just my electronic one. So this is ptable.com. So I know we've looked at this before when we first learned about the periodic table. So remember that you have a whole bunch of information that's on here, but really currently the two pieces of information that are going to be important for an element that we need for this lesson in particular is the atomic number and the mass number. So for example, silicone I have here highlighted, the atomic number is 14. Right, it's the top left-hand corner on this periodic table. And the mass number here is 28.085. Now you're probably wondering, why is it a decimal point? Like, why does it have decimals? And you'll notice that that's true for all of them. So zinc is an atomic number of 30, but a mass number of 65.38. So what this is, what that decimal form value is, the periodic table is showing you an average of all the atoms or a majority of atoms that exist for that element. So those are what are called isotopes. We're going to talk about that a little bit more in depth towards the end of this lesson. So for example, magnesium has a mass number of 24.305. So actually what that means is, in real life, there are some magnesium atoms that are 24, and there are some magnesium atoms that have a mass of 25. So the average that's taken, it really, the number that it is closest to tells you what's the type of atom that is found the most often. And you'll notice sometimes it's a lot of them. For example, hydrogen, I'll give you an example here. See how it's 1.008? So hydrogen has the possibility of having a mass number of 1, 2, or 3. But because the number for the average is very, very close to 1, that kind of tells us that the most common version of hydrogen has a mass number of 1. Right, so if we look at lithium, 6.94. So lithium has actually naturally atoms that are 6, a mass of 6, or a mass of 7. But you'll notice here, because the average is closer to the number 7, what that means is that we have more that have a mass of 7 than that have a mass of 6. Okay, now it's very important that I'm telling you this. When you are doing calculations that are not involving specific masses, okay, so what I mean by that is, let's say we were just going to say lithium. So we're going to look at how many protons, electrons, and neutrons are in lithium. What you would do is you would take this atomic mass and you would round it to a whole number. So 6.94, I'm going to now make that a 7. Okay, now sometimes the question will be specific. It may want to know for lithium 7 or lithium 6. So I'm going to show you what to look for when you know to do that version of it. But in general, if it just says, hey, a lithium atom, you're just going to round that to a whole number. Nitrogen atom, 14, right? Boron, you would round that to 11. So unless you're looking at specific isotopes, you want to be using the average, okay? So let's take a look at this. So notice, so we're going to calculate the number of protons, neutrons, and electrons for the following elements. So notice how it just says iron or it just says calcium. It's not saying iron with a mass of blah, 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 okay? So that means I'm going to take the average of iron, okay? So let's take a look. So first of all, we're going to be doing, I call these our pen numbers because it spells the word pen, but it's protons, electrons, and neutrons. Okay, so let's look at our periodic table. So for iron has an atomic number of 26. Okay, so that means, sorry, I keep flip-flopping back, but that means my proton number is 26 because that's the atomic number. And I know that my protons are always equal to electrons in atoms. So 26 and 26. So for neutrons, let me flip back. I'm going to do the rounded atomic mass, which is 56. 56 minus 26. So 56 minus 26 gives me 30 neutrons. So notice this number the number of neutrons does not have to equal the number of protons and electrons, because remember, the number of neutrons has no impact on the charges. The only thing that the neutrons will impact is how heavy the atom is. Okay, so let's do another one. Calcium. Protons, electrons, and neutrons. So calcium, right, we're going to look on the periodic table. Calcium. So calcium has 20 as the atomic number. So that means, and the mass number, if I round that, is 40. So going back here, so that means I have 20 protons. Protons and electrons are equal. And my neutrons is going to be 40 minus 20, which is 20. So in this case, it just so happens to be the same number, but you're not going to have that for every single atom. Okay, so what I'd like you to do actually is pause the video and try these next two out. So we're going to do the P-E-N number for carbon and the P-E-N number for barium. Okay, so let's take a look. So carbon is 6 atomic number and 12 as the mass number. So let's take a look. So that means here this is going to be 6 and 6, and neutrons is going to be 12 minus 6, which is 6. So like 666 is not a good number, especially for 2020 if this is the year you're watching it. So anyway, sorry, the barium carbon. So barium, let's take a look at barium. Okay, so barium is 56, okay? And then we have 137. So 56 and 137. So 56 and 56, right? And this is going to be 137 minus 56, which is 81 for our neutron number. Okay, so it's pretty straightforward. So if it says the element name, that means you are just going to use the element, the average for it on the periodic table. Okay. Now, isotopes I've already mentioned to you, but essentially what an isotope is, it's an atom of an element that has the same number of protons and the same number of electrons, but what can happen is the number of neutrons can be different. So as I mentioned before, just for an example, hydrogen can have a mass number of 1 or 2 or 3. Okay, now the way I wrote this is very different than just writing hydrogen. So if it just said, what are the P-E-N numbers for hydrogen? Okay, so what that means is you're going to take the number from the periodic table, like you're going to average it out, which is what we just finished doing on the last couple of slides. But if you see it written this way with a hyphen and a number, a hyphen and a number means that you are talking about a specific atom that has that mass number. Okay, so same thing here. If I have hydrogen -3, that means I'm not talking about the hydrogen from the periodic table average. I'm using hydrogen with a dash of 3. So for example, if I wanted to find the P-E-N number for hydrogen -3, okay, so the proton number never changes. The proton number is 1, okay? So the proton number is 1, which means my electrons are 1. But the neutron calculation, I'm going to be using this number instead of the value from the periodic table, because the periodic table is showing me that the average is 1. So if it had said just hydrogen, okay, so let's say here, I just want hydrogen. The P-E-N number would be 1, 1, And then this would be 1 minus 1, which is 0. But here it's not telling me what specific mass, so I'm going to use the periodic table average. But when there is a hyphen and a value, this is the mass number that you have to use when you're doing these calculations. Because remember, the periodic table is an average of all the different types of atoms that exist for hydrogen. When you are saying hydrogen dash 3, that means you specifically want that mass number. Okay. So here's another example. So lithium has 2 isotopes. So this value is the average from the periodic table. So you can have lithium dash 6, or you can use this. You can use the name or the symbol. But what's different when you're talking about an isotope is the dash number. So that means I want the mass of 6, not the average mass of 6.94. So lithium with a mass of 7 would be lithium dash 7, or the symbol for lithium dash 7. So what's different about these two? Actually, nothing other than the fact that the lithium 7 has 1 more extra neutron than the lithium 6, right? So let's do these quickly here. So the P is 3, which means electrons is 3. The neutrons here would be 6 minus 3, which is 3. Remember, you're using this number. And then for the mass of 7, this would be 3 and 3. That doesn't change. But now this would be 7 minus 3, which would be 4. Okay, so literally the only difference between isotopes is that they can have a different number of neutrons. Now keep in mind, if there was no dash number, if it just said lithium or a lithium atom, then you would use the average. Okay, but if it's specific, lithium 6, lithium 7, you have to use that mass number. Okay, so it's just a visual to show you. So if you have lithium 7 and lithium 6, so notice there are 3 protons in the nucleus. That doesn't change. What's changing is this has 4 neutrons and this has 3 neutrons, which is what we just looked at. Okay, so this is a little, we're filling in this chart, but I want you to notice that we're looking at isotopes here. And actually, the format of the way this is written is like an isotope. So copper dash 65. Remember, isotopes are always the element. It could be the symbol or the name, a dash, and then the number for the mass. So pause the video and give this a try. So you have enough information in each line to figure out what is missing and what can be filled in here. So I want you, everywhere where there's a blank, I want you to write down what you think the number should be, or what it should be. It could be a symbol or a word that should be in each of these blanks. And then we will look at this when we come back in the next part.